Hey guys, in this video we're going to be checking out the GEEETECH Mizar S. So I am pretty excited to see what this printer has to offer. So in this video we're going to unbox it, set it up, and do some prints. Hopefully you guys enjoy the video. Let's get started. All right, so yeah, I'm pretty excited to see what the Mizar S here is all about, as it has been a little bit since I reviewed a GEEETECH printer. So this is the box that it comes in. The dimensions of the box, 52 by 48 by 30 centimeters, and the shipping label says 23 pounds, which is about 12 kilograms. So for a long time I've been opening the printers from the top, but I want to try something new on this one. Let's go ahead and flip it upside down and open it from the bottom. And instead of pulling things out, we'll just kind of dump it, and this might work even better. All right, well, I think that worked out pretty well. So yeah, this will be the top here. So we do have some documentation. This looks like some tips page. Probably pretty important here is to check your voltage on the back of the printer, and we'll get to that. A big old thank you card from GEEETECH. That's actually kind of like a card. And the user manual itself. So this is a really nice manual, glossy, thick pages, and very nicely laid out with pictures that are colored. So yeah, very nice. I love to see this kind of attention to detail, even in the manual. All right, so we got a top layer here, and everything is encased in this soft black foam. So here we have a bag of accessories and parts to the printer, and we'll go through this in a second, guys. We also get a little mouse pad, I guess, to use by your computer if you wanted to. We got our power cable in here, and this one is the US type. Part of our spool holder, pre-mounted hardware. Pretty cool looking design there. And that's the very top layer. Lots of good thick foam. All right, so in the next layer we can see this is our gantry, which is the upper portion of the printer. Everything does look like it's pretty much pre-built and ready to go. So yeah, let's go ahead and pull this thing out. Okay, so it is tethered to the bottom or the base, so I can't really move it around too much, but yeah, we can see we got nice flat channels here. What's interesting is we do have some actual 3D printing parts, which is kind of rare these days, but kind of nice to see. But yeah, we'll look at this in a little more detail later on, but one thing I definitely want to mention, there is a dual Z-axis lead screws. Now the only thing that maybe is not so great is that they are not tethered between each other. Normally I like printers that are tethered because, you know, you can easily move one and then the other one moves, but here you can see that, you know, that's not what's going on. So I've seen printers that printed very well with being independent like this, and then some not so well. All right, so I think that's it for this layer. And here you guys can see the bottom layer, which is where our base is. And yeah, everything seems to be packed very well. So again, these two are tethered together, so we're gonna have to kind of keep them together. Pull it out of the foam here. All right, and this is what our base looks like. It's pretty small in the depth, or smaller than normal, but kind of wide also, so it's kind of like a square. But let's go ahead and flip it around. And here we can see the bottom of the printer. We got really large rubber squishy feet. Some venting here, cutouts here where we're gonna have access to connect the upper portion. So I do want to pop this lid off so you guys can see what's underneath. But before that, let's go ahead and see what's in this bag. So we get the other part of the spool holder, which will connect to this piece here. A pretty cheap spatula that's not sharpened, so pretty useless, and I don't think you'd want to use it on this kind of printer anyway. We get some open-ended wrenches and Allen wrenches and some tweezers. A little coil of test filament. Not too crazy about these. Honestly, they're kind of small and hard to deal with, but maybe good for the first little test print. We get a USB cable that connects from the printer to the computer. Some bolt knobs here that are probably for assembling. A pack of zip ties. Our larger 5x35 bolts, and this is going to be what holds the gantry to the base. So here we get some extra parts like the PTFE tubing, a couple extra nozzles, looks like 0.4 size, and also an end stop switch. And it is in a 3D printed case. And the last part here, we get the micro SD card with the USB adapter and also a little tiny Teflon tube. All right, so I'm gonna clean some of this stuff up here and grab the wrenches and we'll open up this back cover. So it looks like we have 8 bolts here to take out, including the ones with the rubber feet here. So I believe that's our last bolt, and let's see if this lid comes off. And sure enough, it does. We do have a fan connected to it. All right, jumping to another camera, let's take a closer look here. So first thing that jumps out to me is this really thin power supply, and that's the branding on it there. It is 350 watts, 24 volts. And the voltage selection here is on the other side, which you definitely want to check before you power on the printer. This is the Y motor here, and you guys can see that the motors are GEEETECH branded. So this is our main plug where the power comes in. It goes into the power supply, and then out of the power supply to the main board. And this is what the board looks like. It's quite interesting. We got an ARM processor chip there, 32-bit. Our stepper drivers there are not removable and also not heat sinked, which I guess don't really need to be on this printer. We got a couple heat sinks here. All our end stop switches here, the wiring, and on the other side our USB port and the micro SD card slot. And also there is a fan that blows right on top of it. From the main board we got a ribbon cable here that goes to the touchscreen display. So the base is completely metal, but we do have some strengtheners here, or channels, that bolt on to the upper portion. So yeah, overall very nicely organized and constructed. I'm gonna go ahead and put the cover back on. We'll flip it around and start putting it together. All right, so everything's back. Let's go ahead and flip it around. So for our next part, we're gonna need these bolts. I think we only need 4, but there are 6 of them. Let's see what the instructions say. So from part 1, they kind of start with giving you tips about the printer and what the best way to use it is. And then we got our parts list there. And for step 3, they want us to go ahead and check the rollers on the bed and the hot end, which I usually do that later on. Okay, so that's not really assembly, is it? Okay, here we go. Assembling the machine, that's what we need. So I find it that doing all the adjustments is, probably better after you assemble it. So yeah, for the first part, we're just gonna grab the upper portion and connect it to the base with the M535 bolts. And there are 4 of them that go through the bottom. So yeah, guys, this part is pretty simple. We're just gonna set it here and you can kind of see the cutout where it'll kind of line up. So probably the most important part is make sure that your wire is not tangled, and if you have to twist it around, but yeah, it's just simply gonna sit in there, and watch out for wires here and there, just like that, and it kind of holds itself. We can just raise up a side and then start our bolts through the bottom. This one's definitely a little bit more tricky, as you do have to find the hole, but it's not too bad, guys. Grab the other bolt and also start it. So we're not gonna tighten these up yet. We're just gonna get where they just start to snug up, and then we're gonna leave it loose because we need to tighten the other side first. All right, so that should be good there. And now let's flip it around. And I went ahead and brought you guys down so maybe you can see it a little better, but yeah, this is pretty simple process here. Now you can use something like a filament spool to kind of prop it up so you don't have to hold it. Let's see, is that even gonna work? Okay, yeah. But yeah, this makes it, where you don't have to hold it and you can kind of just work on putting the bolt in. Or you can even just slide it off the edge of the table and do that. So, and actually another way, you can just set the whole printer on its side and work on it from the sides. All right, so we started the bolts up, and I don't like to tighten them yet because, let's flip it here to the back. The reason is I want to bring the whole x-axis down here. And the reason for that is because we want these to kind of, go a little in or a little out depending on where this wants to be. So let's go ahead and bring it down. So because this is not tethered, like we talked about earlier, we have to spin them both at the same time. But most of the time, this is not an issue, obviously. And you guys can see once I got lower here, they kind of go together anyway, so yeah, we'll go pretty much almost down here. And now we know that the spacing between here and here is as good as it'll get, or pretty darn close. And we can kind of check the rollers and make sure, everything is pretty good, which it is actually. So now we can confidently tighten the bolts up on the bottom, and it'll have just the right distance between the two. So yeah, all we gotta do now is snug them up. And unfortunately, the shorter end of the wrench doesn't go in there. So, you don't have much leverage here. So maybe using the extra bolts here, I can make leverage and tighten it up really good. So yeah, this is a pretty cool trick here that you can add extension to the wrench. All right, now let's do the other side. And there we go. We are nice and tight and hopefully exactly where we need to be. All right, so for the next part, step 3, it looks like we have to install the Y-axis end stop switch, and that was the extra switch I thought was the extra, but this is the Y-axis. So if we flip our printer around, looking at the back, we can see, maybe you guys can see, there's 2 little threads here on top and a plug. So let's go ahead and take this out of the bag. And this is what it looks like. It's actually 3D printed, and if we, let's see, take off this cover, you guys can kind of see the end stop switch itself. It is one of those optical kind or sensing kind, and yeah, the case is just 3D printed, which is quite interesting because I haven't seen this in a while. Pretty cool. So yeah, we'll just need the right wrench here, and with the plug facing towards the back, we're gonna tighten it up right here. So you don't want to over tighten this, as you know, this is a 3D printed part. And yeah, that should be good right there. And I think we can go ahead and plug this in. So I'm going to go ahead and do that. And that is the Y-axis end stop switch. So for step 4, we're going to put the spool holder together. And so the way this goes together is, this is going to be the front here, which is our nicer part. And then the plastic spool part, the holder, is going to go towards the back like that. And then the locking nut towards the front. And just twist it and it locks. Yeah, simple as that. So looking at the top of the printer, we're at the back. Let's go ahead and flip it around. If you're looking towards the front, on the left side, this is where our extruder is and where the filament will feed. So the spool holder needs to naturally go like this. So the spool goes to the back, just like this on the rail. There are T-nuts on the bottom that are going to line up with the channel and then fall in. The way they work is actually not too hard, that they do fall into the channel. And what you want to do, and you guys probably can't see that at all, but you want to unscrew it so the T-nut can drop down, and then once you tighten it back up, it's going to turn in the channel and lock in. So the T-nut literally sits like this, and then it turns and locks in. So if it's not locking, unscrew it and then screw it back in. You do kind of have to make sure that you're lined up centered with the groove. So just unscrew it and then screw it back in. It should turn and lock in. And you can kind of peek through the sides to see, you know, if it actually turned. And that's the way the spool holder goes on. And the way I like to do it, guys, is go as far that way as you can, because if you go more towards the middle, it does look maybe a bit nicer, but then you're going to have your filament more of an angle because it does go from here to there. So the farther out it is, the better. So for the next part, which is step 6, is we're just going to simply insert this PTFE tubing into the other end here, into the extruder. So there is a little blue clip that clips into the coupler there. So we got to take that out and then just simply insert the tubing. So you want to make sure it goes in there. And then we're going to put the clip back in so it can expand the coupler to hold the PTFE tubing in. So simple as that, we should be good to go. And just realized you guys probably didn't see any of that, but yeah, it simply just goes in here. So the little clip. All right, I think we're pretty close to being finished here. We just need to plug a few things in. So we'll flip around here. You can see the Z-axis motor needs to be plugged in on this side. And we did install our Y-axis end stop switch there. Our other Z-axis motor needs to be plugged in. And then flip around to the other side here on the front. Our Z-axis end stop switch needs to be plugged in. There we go. And if we keep flipping around to the other side, we can see we actually have 2 Z-axis end stop switches, and this one also needs to be plugged in. And I believe that is all of the plugging in. So seeing that it has 2 switches for the Z-axis makes me feel a little more better about its accuracy. All right, so for the next part, I think what we need to do is we need to adjust the rollers on the bed and the X-axis, and also these rollers here if they need to be adjusted, which on mine, they're actually pretty good. Yeah, for mine, I don't even need to adjust these. So yeah, depending if you do, the adjusting eccentric nuts are on the inside. And you will need a wrench that came with the printer to adjust them. So we'll start with the bed. There is some foam here that I haven't pulled out yet. Kind of keeps it from moving around. But yeah, the way it works is that we have channel here, and there's 2 rollers on each side that will roll around it. And so what we want is we want the rollers to be tight enough where the bed is not moving, but not too tight where it eats up the roller over time. So that's quite important. You want to make it as loose as possible where the bed doesn't move around. So if we go to the side here, actually this is just the upper portion here. Okay, yeah. So yeah, this is the build plate and it's individually wrapped, but we'll take a closer look here in a second. Let's go ahead and adjust these rollers. So the 2 adjustable ones are on this side. And go ahead and prop this thing up, will be easier. So the whole idea here, guys, is that you want them to spin pretty easily. So you can just grab your finger and spin it in one spot, kind of like a little burnout. If you can do that, and it's not too tough to spin, and the bed doesn't wobble, you got yourself a perfect adjustment. So it looks like I'm not gonna have to do anything there, but if you did have to do it, you would just turn the eccentric nut one way or another to get the wheel closer or farther away from the channel. So hopefully that made sense. Now we do have another issue, which our belt here is way too loose. It's just not tight enough at all. So we do need to tighten that. And looks like the adjustment for that is right here in the front. So we're simply just gonna turn this clockwise to tighten it, and it tightens up. And so on the belt, you also want them looser than tighter, if that makes any sense. You don't want to play any kind of notes on it. So if you hear even anything closer to a note, you're too tight. So I think I'm pretty good right there. Maybe I'll loosen it up just a bit. There we go. Yeah, I'm pretty happy with that. So again, no note playing, and looser is better than tighter. All right, so yeah, our y-axis here is good. Our rollers are good on the bed, and our belt is nice and tight and seems to be running even on the pulleys. So let's go up to our x-axis, which is our hot end here, and we're gonna flip the printer around. And we actually need to bring it up a bit. So here we have the same situation. We have two stationaries on top and an adjustable on the bottom. So for this one, I can already feel that it's too tight. And even though I can spin the wheels, they're very tough to spin. When I move it back and forth, I can kind of feel there's some jumping and jittering in the movement. So what we're gonna do is grab our wrench, and we're gonna try to loosen it here, whichever way that is. Okay, there we go. So we've loosened it quite a bit. So you can kind of feel by the wheels. You just want decent friction. Now if you go too loose, it'll start wobbling like it is now. So I just need to tighten it just a little bit after that. And there we go. That should be good right there. The wheels spin pretty freely. It's not wobbling, and it has a very smooth motion. So yeah guys, not complicated at all. You just gotta, adjust it correctly, and you're gonna have nice smooth travel. Now speaking of smooth travel, we can also adjust our x-axis belt right here on the other end. If you're looking at the front on the right, we also have a bolt here that tightens and loosens, and our belt here is way too tight. I want to loosen that up a bit. Move this back and forth, make sure the belt is happy on the pulleys and everything seems good. Check it again, perfect. And I think we are good right there. That's pretty much how it goes. And on these rollers here, you have, these are stationaries, and then the inside one's adjustables. So this is not as important. If it's close, if they're not completely perfect, it's not that big of a deal, because the z-axis doesn't, move a lot and fast. It just slowly moves up. So as long as there's nothing too out of place, you should be fine. Now, if you're binding and, really too tight or just completely loose and not grabbing anywhere, you want to adjust it then. But if it's pretty close, I wouldn't mess with it, because it's not as critical, and also sometimes you can't get them perfect like you would want them. Yeah, don't worry about it too much. As long as it's close, it should be fine. All right, so we're pretty much done assembling this thing and adjusting it. Let's take this build plate out of the bag. And I really like this finish. It's like a matte blue material. It does feel pretty nice, and got a little GEEETECH logo here. So it's like a metal sheet that's flexible. I really like these. When they do work, they're awesome. And on the bed here, we have a magnetic sheet that this magnetizes to. So it's quite easy to line it up. And it's quite strong when it does hold, so it's not going to move for sure. It's great because, when you're done printing, you can just pull it off, set it on the table, and it really cools off fast. And then the models just will pop off, just flexing it a bit. So for the next part, let's go ahead and take a closer look at all the details of the printer. So looking at the printer here from the side, it looks really nice. And some of the blue that it has, it stands out nicely. So let's start here from the top. This is our spool holder. So we'll grab a spool here just to demonstrate real quick. So yeah, our filament will kind of go like this and then down, and through the detector into the dual gear extruder. This is a great extruder that's pretty powerful and has dual gears. You guys can see one here and then one inside, which drives it. So yeah, it's a very consistent kind of filament feed into the hot end. But looking at the back here, we can see we have two guides here on the top for the lead screws, but they don't actually have bearings. It's just kind of plastic guide, or at least that's what it looks like. So we got a 20/20 channel on the top, and then 20/40s both sides going down. Spool holder there, far this way as we can, again, as we talked about, so we can have a good curve here for the filament. Here's another look of the detector here going into the extruder and the extruder motor. So the lead screw comes down. We have anti-lash springs with brass bushings going down into coupler here with the motor, and same thing on the other side. This is what the back of the hot end looks like, and the wheel we adjusted. You guys can see we have a cooling fan, axial style, and a silicone heat block sock there. So going down to the bed, it is aluminum with the magnetic sheet there that magnetizes the build plate. And underneath, you guys can see we do have a heated bed, but it is not insulated. So the Y-axis rides on 2 rails that are kind of separated, and there are 4 rollers on the bed that go around it. And this is our gear for the Y-axis motor, which is down inside. Going over here, we can see this is our Y-axis in-stop switch. So down below that, we have the power input socket. It is fused with an on and off switch. And going to this side, this is where our switch for the power supply, selecting our voltage. I'm not sure how well you guys can see that, but we are actually set to 230 volts right now, which is not correct for me. So I'm just gonna grab this Allen wrench and switch it over to the 115, and now it's where it needs to be. So you definitely want to check this, because if you don't, you could have trouble with the printer, or worse, even burn it up. And on the very bottom, you guys can see those large feet, and there are 4 of them. So now we are back up front, and we can see our channels got this smooth finish. They still have a groove in them, but it's, you know, kind of a nicer finish than usual. Also same finish here. So on this side, we can see a little cap here with the GEEETECH logo. Make it possible. X-axis in-stop switch is actually the normal mechanical kind, and the Y and the 2 Z's are the sensor style. So this is our X-axis motor, and then the gear. If you look below that metal tab here, that goes into the Z-axis in-stop switch, and same thing on this other side. This is where we adjust the X-axis belt. Looking a little closer at our hot end, we got a sticker here, high temperatures. We do have a clip here also for the coupler. The hot end itself is actually not too large. It's got all this venting around it. Looks pretty nice. And on this side, we actually have a couple threads there that must have some kind of accessory that can be installed there. Yeah, you guys can see the fan duct there with the hot end, heat block, and the nozzle. And also, guys, if you see that little white thing right there, that looks like maybe an LED light of some sort. So going down from there, we saw the build plate already. It has this nice little tab. You can pick it up. So this is where we adjusted the Y-axis belt, the tension. Here we have the manufacturing label, the model number, the max temperature, the voltage inputs, max bed temperature, print size 255 by 255 by 260, and the platform size is a little larger than that, which is 260 by 260. Going down from there, we can see this is where we plug in the USB cable that goes to the computer and our micro SD card slot. So the front's pretty clean until we get to the right side, which has our screen. Let's go ahead and peel off the protector here. And it is a pretty nice large touchscreen display. Nothing too much here, some venting, and some venting on the other side. All right, guys, so for the next part, I'm gonna plug it in, turn it on, make sure everything works, check all our axes, preheat it, and then level the bed. All right, so I got the printer plugged in. Let's go ahead and hit the power button, see what happens. All right, so it beeped, the screen lit up, and it looks like it booted up very quickly, actually. All right, so I'm gonna click on tools here, and we have a home button, so I'm going to click on that. So we're going to make sure that everything works. Okay, so it's moving up to the side, so that's the X. The Y is working, and now it's going down, and it's very quiet, by the way, especially on the Z. I'm actually very impressed. Normally the Z sounds are quite loud. And there it goes. So the great part is that it individually reads each side, so it's going to be perfect each time. All right, so all of our motors work and switches. You probably guys noticed that we didn't have any knobs, and I forgot to totally mention that. And the reason for that is because this printer does have out of bed leveling, so you can't even adjust the bed up and down or corner to corner. It's just pre-adjusted, which is quite interesting and, you know, kind of a bold move on the design, because, you know, you really have to be pretty close in order to compensate with the out of bed leveling. But this is what this printer does, and let's see how well it does it. So I don't know if you guys can see here on the bottom it says auto leveling, so I'm gonna go ahead and click that. So it looks like it's gonna auto bed level, and then we're gonna do the Z-axis F side. So let's click on that. Okay, so it's actually asking us to use a tool of some sort and just to push on the nozzle, because it wants confirmation that, I guess, it's working. So it does appear that this has one of those strain sensors in the nozzle, so when the nozzle touches something, it feels it. So because I didn't do it quick enough, it kind of canceled the whole thing or failed it, but we can restart here. So it's asking us to touch it, so let's go ahead and do that. And there we go. Now here it's showing us it's going to go through the 9 points and take measurements. And it is preheating the nozzle to 130C and the bed to 60C. Now hopefully you guys can see that. There might be a little too much glare, but yeah, it's pretty straightforward. And right now we're just waiting for the machine to do its thing. So the screen is tilted about 45 degrees, which is nice when you're looking at it from top down, but maybe not so nice when you're looking at it straight at it like this. So, all right, so the nozzle's hot. The bed is at 52 going to 60, and yep, I can definitely feel it. It's getting toasty. All right, so it looks like it's ready to do its thing. All right, so it's taking its first measurement, and you can maybe see the 1 is flashing green over here. All right, so it's done with 1, now it's going to 2. And it is doing a double take, 1 quick one and then 1 slower one. Okay, so that was kind of interesting. It went back and homed until it finished the 8th point. All right, so we are on our last one here. Some reason it's taking extra measurements here. Just keeps doing it and doing it. Very weird. Okay, so it says that it's done. And it looks like it's homing. Okay, so I guess we need to hit the back button now. Now we can adjust the Z offset, and it is available. Before, actually, this was not available. So yeah, after it does its automatic leveling, it presents the Z offset button. So let's click on that. And we need to click on start to begin. So we're gonna need some kind of paper. I'm just gonna use this tips paper that came with it. And I can see already that we're definitely too low. So let's go ahead and bring it up. So we got down, up, and then increments. We're at 0.01 right now, so we'll keep it at that. So let's keep going up a little bit. All right, so we're just gonna adjust this until we have a nice drag on the paper. You can also kind of eyeball it under there. I think I'm pretty happy right there. So yeah, guys, it's not too complicated. Then we're just gonna click the save button, and it says successfully saved. And our offset is 0.39 plus. So yeah, quite a bit up I had to go. So let's go back here. Let's go ahead and home the printer again. We'll grab our little SD card, which is a 4 gig, and this is where it plugs in, probably upside down. Yep, and it does click in. So let's see if we have anything on there to print. So we're gonna click on printing, and sure enough, there are 3 folders there, or files we can print. We got a rocket, a G, and owl, looks like. So I guess maybe we'll print one of these and see how it turns out. But before we do that, let's take a closer look at the screen here. So these are our files here. We're in the SD printing mode here. So as you can hear, it does beep every time I click something. So this is the tools. We got preheat, PLA ABS buttons, very nice, and also a cool button. And it looks like here you can do a custom preheat also. So if we click on PLA, you guys can see it goes to 190 and 60 on the bed. So let's go back. And by the way, the screen is nice and bright and also has a good detail. Filament change, so we can control the extruder here to load and unload. Move is going to let us move each axis individually, and this is the amount you want to move. The home button takes all the axes to its home positions. And then we got the auto leveling is what we did earlier. And then the Z offset, which if you do need to adjust it, you can go back here and, go up and down. We also have manual leveling, and I guess this will let us manually adjust it ourselves. And then we have a motor unlock. So this just releases all of the motors. Let's say if they're like you can't turn it by hand or move it by hand, you can release them here. And that's pretty much it for tools. And then the settings, we got run out filament sensor, and you can turn that on and off. So it was actually off. We do have one, so let's turn it on. And then our language is English. And if you click on it, it changes to Chinese. So let's go back to English. Here we have the sound. So you can either turn it on or off. So I'll probably leave it on. And then we got the LED control, which turns on the light and off. And it was actually on earlier. And the last button here is about, and this is everything about the printer. And we do have a restore button here for whatever reasons. All right, pretty cool. Yeah, that's pretty much everything and quite simple. We'll also check out the menu once we start printing and what's available. All right, so now that we know that we have something to print, let's go ahead and put the filament in. So we've got to make sure that we're preheating, or we are preheated. I think, yeah, we are already. Well, that's good. So let's see if I can move you guys to the side so you can see maybe a little better. All right, so we got our filament coming from the top. You want to go ahead and cut it on an angle. That way it feeds better through the different parts we have to go through, like the filament detector here. So we'll go right through that. And then after that, we're going to go into the extruder. assembly. Once we go inside, what we need to do is relieve this lever here by pushing on it this way, and then we can feed our filament through. Now you can use the software to feed it through, but I find it a lot easier just to do it with your hand and much quicker. So that's what I'm gonna do. So I'm just gonna run it through there until it comes out the hot end. Hopefully you can see that here. And there it goes, it's coming out. I'm just gonna push some of it out there to purge it. And here on the extruder arm, you can adjust the tightness of it. So, you don't need to make it too tight. As long as it has some decent pressure on it, which mine definitely does, it should be good. But yeah, we are pretty much ready to go. We purged the filament. Everything's preheated, leveled. So let's go ahead and click on printing. And I guess we'll just go with the first file, which is called Rocket. And hopefully it's not too big of a file. Okay, so it says Rocket Plane, 1 hour and 14 minutes. Okay, that's not too bad. Let's go ahead and start with that as our first print. So we're gonna confirm, and there it goes. And we get a whole new menu here. Actually, it looks pretty awesome, but yeah, I'll zoom into this in a second once we start printing. But let's get closer here so we can see better. Remove this little booger here. All right, so there it goes. That was pretty quick. We were preheated. Hopefully our offset and everything else is good. And there we go. Okay, we're definitely way too close. So under options, we do have baby steps. And for some odd reason, guys, we had to go up quite a bit, a whole 1.1 millimeters there, or at least. So we did kind of scratch into the bed a bit, so it'll probably leave a mark. Well, that's kind of unfortunate. Thought we did a pretty good job there doing the offset, but for some reason, it was way too low still. Very weird. We are printing now, and I think we're good. Yeah, I guess either we did something wrong, or maybe the way the file was sliced, for some reason it started way too low. So our light is on there. It might be too bright. I wonder if I can turn it off. Okay, yeah, looks like I can. Okay, it's RGB, I get it. It's actually called color here, so it's either off, white, or color, and that's gonna go through the different RGB colors, or off. So I'm gonna turn it off for now so we can see a little better of what we're printing. So let's take a closer look at the screen here while the printer's printing. So on the top we can see our file name. We got the GEEETECH logo, percentage bar, the time passed since we started, the nozzle temperature and the target, the bed temperature and the target, the speed 100%, moving at 15 millimeters a second at this point. Feed rate's 100, Z-axis, and you guys can see that it's going up, and I think it's doing spiralized mode. That's why it's going up and up. So. And here we have our fan speed, which is 255, meaning full power. On the bottom, we have pause, stop, and options. We click on options. We can adjust our temperature on the nozzle. And also on the bed, if we hit this button here, it switches between the nozzle and the bed. Here we can change the filament. We're not going to do that. Adjust the fan speed. Turn our light on and off like we did earlier. Turn on the run out sensor. So you can turn it on and off on the fly, the detection for the filament. The speed of the print, we can make it go faster or slower. And here we got the movement between the extruder and the print itself. And then the most important one here is the baby steps, which is really nice to have this. And this is what I used to adjust it. You guys can see plus 1.13 offset. And this was just a rough, quick trying to go up because we were kind of scraping into the bed. Yeah, lots of good controls here and very well laid out. And the screen is very nice and bright. So for the next part, I'm going to bring my microphone in and you guys can hear the printer. So overall, it's very quiet. The only thing I can mostly hear is the fans, and the stepper motor sound is completely not audible, at least that I can hear. So, but overall, it's definitely on the quieter side. All right, so I printed this first spaceship and actually didn't turn out that good. So I printed another one with other filament and it was perfect. So I guess this filament is really old or something, but yeah, it just turned out not very good. You guys can see there. So yeah, I figured something was wrong with the filament and it's actually a really old filament. I think it's over 2, maybe 3 years old. So I either got to dry it out really good or maybe just throw it away. But in any case, we printed another rocket plane here and it looks like it turned out perfect. But yeah, it did take 1 hour and 17 minutes to print. So let's go ahead and take it off. It's pretty much cooled off at this point. And you guys can see it's stuck to the bed. So let's go ahead and break it loose. This is pretty fragile because it's one layer. I'm not sure how good it's going to come off. Well, it did came off pretty well. And you guys can kind of see the mark that the first one left. It was kind of severe. But yeah, The second one here popped off really easily and no issues. So looking at it, you guys can see it looks quite impressive. But yeah, if you guys look at the walls and everything, wow, this thing looks pretty incredible. Let's see how close can I get here. Yeah, excellent layer adhesion and consistency. A really good start here on this first print of the rocket plane. And even here all the way up comes to a pretty small point, and it did pretty well there too. There is like a little bit of a layer shift right there, if you can kind of see. Yeah, very cool little print. Actually, it looks nice. I like it. I think for the next part, what we need to do is go to the slicer, slice some of our own prints like the Benchy and a cube to do some benchmark tests with silky black filament, and that'll show us a lot better of what we're looking at. All right guys, so here we are at the computer, and I have the micro SD card plugged in, and when we open it, this is what we see. So the first one is a PDF of the manual. So it's just a manual that you get in digital form, which is kind of nice because you can, look at it on your computer and kind of refer back to how to use everything and things like that. And here we have some machine parameters that could be interesting for some. All right, so we have the 3 G codes, which we did print one of these, the rocket plane. So this folder here is a slicing software, and they have a couple choices here, Cura and Repetier. So I use Cura. So there is a PDF of how to install it with the link, and then how to adjust the print settings. Troubleshooting guide helps you with troubleshooting some of the things about the printer, which is quite nice that they include so much information. So quite a bit to learn here, and they really go into detail, guys. You can see this directory here of all the possibilities that, things that can go wrong or how to troubleshoot certain things, which is quite impressive, honestly. This is a lot of detail about the printer. So here we have a folder of models, looks like. So yeah, they actually included quite a few STL models. Pretty cool. Here's the rocket plane that we already printed. And we got quite a few things that technically could try, like this bell here, I guess. This pretty interesting print here. Looks like a fox or something. So yeah, these are, great ones to start off with just to practice to do some printing. And we also got some kind of Christmas tree star separate folder. So okay, so it's like a 2-piece print that you can print for your Christmas tree. All right, well, that's nice. The rest of the files are just videos where they show you how to do certain things like level the bed, and also an unboxing video. So let's go ahead and open up Cura. And we'll click over here where it says the printer. I got the Ender 3 right now. I think for this printer, I'm going to use the CR6SE profile because it also has that same kind of strain sensor on the hot end. But if you didn't want to do the A20, you would just click here, add printer, and then go to non-network printers, and then find GEEETECH. And here we have the A20. And when you click add, so the parameters didn't pop up, so we can go to manage printer, machine settings, and here we can see pretty much all of the parameters. But I'm just going to go ahead and use the CR6SE profile. And if we go to machine settings, we can adjust everything that we need to. So we can go 255 by 255, and then everything else should be just fine the way it is. Close. So this is our build volume. Well, let's go ahead and throw a calibration cube in there. So I'm not going to go through how to use it, but on the side here, we got all of your major functions like move, scale, things like that. Let's click over here where we can adjust the parameters and check everything, make sure it's good. So we got layer height of 0.2, wall count is 3, top layer 5. Now I'm going to fill the gaps so it can be quicker. Infill at 20% is good. Temperature 205, initial 210 should be good. 60 on the bed, 50 millimeters a second. Enable traction 6.5 millimeters at 25 speed, and this might need to be adjusted, guys, because we do have that dual gear extruder, so maybe the speed will need to go up. So if we have any trouble with retraction, so we can adjust it here. But yeah, pretty much everything else is standard, and we got skirt 3 lines around. All right, so yeah, I like to use these same parameters on all the printers. That way all my tests are pretty consistent between printer to printer, as they do pretty much operate the same way. So slicing that gives us 45 minutes to print. So let's go ahead and save it to the removable, and it's saved. So we're not going to inject it yet because we're going to go ahead and clear the build plate and throw the Benchy in here and slice it exactly the same way. And this is going to take 1 hour and 58 minutes, so under 2 hours, which is pretty quick for a Benchy, as there is a lot of retractions. And we'll go ahead and save that to the SD card. So if we open it up, we can see we got 2 new files here that we sliced. I mean, this is pretty standard stuff for the slicing and moving files to the printer, but you can play around with all the parameters and different settings and even the different printers here, including the recommended A20, to see where you're going to get the best print. So, all right, so I'm going to go print these out, and hopefully this little quick overview was helpful. All right, so the cube and the benchy are finished. I'm liking what I'm seeing right off the bat. So let's go ahead and take a look at the cube here first. So this is the x-axis. You guys can see it turned out really nice and the surface is really smooth. The y-axis, we got a little bit of vibrations, but no ghosting almost at all. So that's a really good sign. X wall and the y wall. The bottom, we had a little bit of under extrusion there in the beginning, but it stuck on really well and popped off easily. And this is our top, also great. So yeah, the cube turned out extremely well, and you guys can see how nice the layers are put down. Now the benchy did have a few issues, but let's go ahead and pop it off here. So the bed's cooled off and I haven't pulled it off, so let's see how easy it comes off. Okay, so it's actually stuck on there really good. Wow, kind of surprised. But yeah, it does pop off pretty easily. But whatever this built surface is, it actually sticks really good. But also seems not too hard to pull off, especially, you know, on a larger model, you'd just be able to bend it and it'll just come right off. So, all right, well, here we have the benchy. So let's start here from the bottom. So it looks pretty good on the very bottom. The side walls there, the layers are sitting really nice and smooth. There is a slight layering here and there, but nothing too severe. And this other side here, a little bit of under extrusion there. This is our seam. So overall, I'd say it, you know, did pretty good there. Now, the main issue, if you guys can see maybe, is the side walls. It's actually mostly the retraction is where the issue lies for some reason. And you guys can see we have stringing. And we set our retractions to 6.5 millimeters, but it's still either not enough or something. The issue that it's having is not so much accuracy or flow, but retractions. I guess I will have to play with it a little bit, see if I can get it better. But yeah, this is pretty much the standard that is used for everything, and since we do have Bowden tube, you know, 6.5 is quite reasonable retraction. But initially here, I'm really happy with what I'm seeing. You know, our layers do go down really well. I'm gonna go ahead and print out a few other models and we'll take a closer look at those. So one thing we totally forgot about are these little knobs. They are actually tensioner knobs for the belt tension. I'm not sure why they were not pre-installed, maybe because they're a little longer, but it is pretty simple, especially on this one here. We're just gonna take the little bolt out and then screw the knob in. And that's the tensioner. So this is for the X, and here on the front we have the Y. And do the same thing here. Make sure our belt is tight and we're good to go. So yeah, if you want to replace your bolts with these little knobs, you can do that and it's a little easier to adjust. All right, so these are all the prints that we printed. Some of them turned out amazing and others not so great, but I realized after printing for a bit that some of my filament's actually going bad. Yeah, I guess I need to either dry it out or maybe just get rid of it. But in any case, let's go ahead and look at some of these models. So we've seen the calibration cube, the benchy, and then our plane ship here. So let's start off with the red benchy. And the reason I want to start off with this because I want to show you guys that it actually printed better than our first one, which was in black, because of the different filament. Now it's a little harder to tell the reflections, but you guys probably can still see. So it turned out even better, meaning that it wasn't as stringy and also the walls look better too. So yeah, filament has a pretty big role in how your prints turn out also. Most of the time I kind of ignored that for a while because I've just been using the same filament, but I've noticed I've been having a little more trouble lately, and part of the reason is I think I've been exposed to a lot of humidity and weather that's kind of ruined the filament. Even though I do dry it once in a while, I haven't been taking care of it as I should have. The benchy can look really good compared to the black one we saw earlier. So this little froggy here is actually a pretty detailed print, and this filament is also not perfect. We can have a little stringing and a little inconsistencies and things like that. But yeah, you guys can see how the printer does really well, and even under here where we have a pretty hard angle, it did very well. And the little fingers are also pretty hard to make them perfect. So yeah, the printer does an excellent job, guys. So the frog looks great. Now here we have a Squirtle, which I guess is a squirrel slash turtle. Got a shell there. But this is a filament that I just took out of a package. And it's some kind of, non-known brand. But you guys can see how much of a difference it makes when you have the right filament. Everything is very nicely laid down, and yeah, even a pretty cheap name brand filament can look really good when it's fresh out of the bag. And with this printer, you can see how well the layers go down. So this is silky somewhat, so it really reveals under certain lighting the layer lines, but under normal lighting it looks amazing. Here we have a print with just normal filament I had laying around, and this one looked like it was in pretty good shape. And by the way, guys, I don't know if I mentioned, but most of these prints were printed in 0.2 layer height at 50 millimeters a second, 200 on the nozzle and 60 on the bed. So we can see here how nice the layers go down, and you can even see the model forming those little lines there. That's actually part of the scale, and as we go up, you can kind of see the polygons go away, or the structure parts, I guess. Very nice print again. The layers go down beautifully. And by the way, all the prints stuck very well to the build plate and popped right off, except for that little mistake we had in the beginning. For some reason, the nozzle was too low and it kind of, engraved into the bed a bit, but it didn't harm it. It just kind of made a mark, and it's not even that bad. And I did go back actually to the tools and redid the automatic bed leveling, and my Z-axis offset became 0 again. So yeah, I don't know exactly what happened in the beginning, but something got thrown off. So if you do have trouble, just redo the auto leveling again. And that fixed all my problems, and it's been flawless after that. Here we have a pretty simple but interesting print. So it's, I guess, flexible one with the shape of a unicorn. And I guess it was pretty fun to print, and it was included with the printer. So, but yeah, there are links here in between, and so they kind of connect together. So it's semi-flexible. Yeah, pretty cool little print here, and the quality turned out pretty good. And this filament here is just random filament laying around. So maybe not the best, but overall the layers went down beautiful. Another print that's pretty fun to print is this little octopus. This print here shows how well the bed works, because we have individual little legs printing on the bed, and then they all connect and become these functional little tentacles. And yeah, this is a really cool print. And the reason it's this lighter color is because it's printed in glow filament. And I don't know if I can, maybe you guys can see there, kind of. Maybe a little hard to see, but it does glow. And this one turned out really good, even though you guys can't see very well. But yeah, this filament here prints excellent. And we had a ton of retractions between all these pieces. And yeah, it looks really nice. So the next print we got here is a bearing, and this is actually a functional print, and this is the way it printed out. So the walls look pretty nice. The bottom is pretty good. I kind of ripped off some of the filament there, and this is before I re-leveled the bed, so it was still a little close. But this is supposed to be functional, and I'm not sure if it's gonna work. I haven't even tried yet. Let's see if we can stick this Allen wrench key in there. Okay, so that's a good sign. It does go in. So let's go ahead and twist it. Okay, so it's moving. Okay, there it goes. So it broke loose pretty quick, and now it's moving. And it's actually turning really good. I mean, there's a little bit binding here and there, but it's pretty nice overall. So let's see if I can pull out the wrench and do it by hand. Show that it does work. Yep, there it goes. So yeah, guys, this shows that this printer is very accurate, because you have to be pretty accurate in order to make a functional part like this. And also all these pieces, they print separately on the bed, and the printer just continues to impress. So yeah, that's all of our smaller prints. Now I did do one more print, as you guys can see, the Spaceship, and it's actually in Spiralize mode, which is a few layers on the bottom and then just one layer all the way around, so it's really thin. And this print did have a little bit of issues. Now it did print all the way to 260 on the height, but as you guys can see, it didn't really finish well, and I just dropped the whole piece inside. But yeah, let's start with the bottom. So the bottom stuck very good and it popped off pretty easily. But as far as the layers go, they are very, very nice, guys. I don't know how well you can see, but yeah, the layers are sitting good. And this is silky gold filament, and it's a brand new spool, so yeah, we should have pretty good results here. But yeah, if you look at the reflections, you can see it turned out just beautiful. So not much ghosting or anything weird. Everything looks good. Usually these windows have pretty heavy ghosting, but there's no ghosting at all, which is quite incredible. Or any kind of ringing, especially around this G, it gets really bad. Now, there is a tiny bit of it, but almost unnoticeable. Now what I believe happened, because this is a dual Z-axis setup, and this is one of the issues that you could run into with dual Z-axis, is that if the left and the right side don't equally go up, you're gonna have just a little bit of tilt or shift, and that's gonna cause a layer not to bond, and eventually it, just doesn't stick. And we started seeing signs of that right here, and then as it went up, it had a more severe one here that just, I can pull this out, tried to recover, as you guys can see, but then it had, you know, more layer shifting there, and it just kind of went all melty from there. Surprisingly, it was still able to finish to the top, but you know, that's not really successful at that point. But yes, where it did print, it looks great, and maybe it's just the filament is not as sticky or needed to be sliced a little different with a little bit extra extrusion on the multiplier to give it a thicker layer. But in any case, you guys see that this printer does an excellent job of putting the layers down. So if you have good filament, you're going to get good results. But if your filament's not great, obviously, you know, you're going to have some issues, just like with any printer. So I think overall the Mizar S here is an excellent overall printer. Very easy to get started. You guys saw the assembly was straightforward and simple. It's all metal and built very well. Definitely one of the best parts is the out of bed leveling that takes care of leveling the bed, which makes it very simple to get going. So this would be great for newcomers. The little LED light underneath is pretty cool. It is RGB. We do have silent steppers, which the printer is very quiet. I like the build volume of 255 by 255 by 260, and I definitely love the steel build plate sheet that pops off and easy to flex to get the models off, and it is magnetic. Easy to adjust belts on X and Y with knobs. Nice touchscreen display, very well laid out and bright. We got filament detection, and you do get all the modern features like overheat protection and resume printing after power loss. So yeah, overall I really like this printer. I think GEEETECH did a really good job with it, and if you're someone that wants to get into printing, this would be a great machine to start with. So if you are interested, I'm going to leave some links in the description. Check it out. And if you guys did enjoy this video, then hit that like button. If you do enjoy videos like this and you want to see more, stay tuned. I got a lot more 3D printing stuff coming up, and also check out the 3D printing playlist. You might find something interesting there. So as always guys, thanks for watching, and I'll catch you on the next one. Peace.